piece of land. There's not a trace of green, which implies a lack of food production and most likely a lack of wealth also. That was true for quite some time, like these pictures show. Surely this place hasn't changed much, right?
Так дайте пацанам посчитать потери. Суммы нули погибают на сцене. Снова один, прогуляюсь без денег. Заливаю один поцелуй на шее. Капитал план, правда назад, черный каскад. Вижу твой взгляд, степ многоярд. Мог тебя взять, но ты не моя. Так дайте пацанам посчитать потери. Суммы нули погибают на сцене. Снова один, прогуляюсь без денег. Заливаю один поцелуй на шее. Капитал план, правда назад, черный каскад. Вижу твой взгляд, степ многоярд. Мог тебя взять, но ты не моя. Так дайте пацанам посчитать потери. Суммы нули погибают на сцене. Снова один, прогуляюсь без денег. Заливаю один поцелуй на шее. Капитал план, правда назад, черный каскад. Вижу твой взгляд, степ многоярд. Мог тебя взять, но ты не моя.
Well, in 1938, in this particular region, a significant deposit of this was discovered. Though not drinkable, and certainly not delicious, it was the stuff that your car ate, not grass. Technically speaking, grass and oil are not too dissimilar, in that they both contain some degree of energy. Energy is what you need to enact changes, like for example changing your location from Berlin to Paris, or bringing your dog outside for a walk. However, on average, grass provides much less energy than oil, so you don't always find a horse in a Formula One race, or a car on the horse track. So what are the secrets behind this tremendous power? To be fair, that's not even a secret, because you can smell it, the smell of hydrocarbons. You can already guess the only two elements that are found inside these chemical compounds. The thing with hydrocarbons is that when you burn them, you get carbon dioxide, water vapor and most importantly a shit ton of energy. Why, you ask? On the left-hand side of the reaction, we see bonds between carbon atoms and hydrogen atoms, as well as bonds between the carbon atoms themselves. Don't get me wrong, these bonds cost a lot of energy to break, which is why we have to burn them in the first place. However, when the carbon and hydrogen link up with the oxygen, the resulting bonds release more energy than is required in the previous step. This is because bonds with oxygen are harder to break than hydrocarbon bonds, and therefore you rarely see water being split into hydrogen and oxygen. As powerful as it may be, this black stuff can't go in your car just yet. In French, this green stuff is called
essence,
due to its refined nature as a distillation product of crude oil. Among the mixture are components of different boiling points, with gasoline being the most easy to boil. When you heat the petroleum inside a fractional distillation tower, components with the same boiling points will stay together in separate chambers. This allows for the easy obtainment of the component that you actually want, like gasoline, which is caught in the topmost compartment of the tower. However, this might not be enough, and the way to get more is to break down the heavier components into gasoline-grade molecules. This is accomplished by the aptly named process of cracking, which literally cracks longer hydrocarbons into smaller ones that go upward. From here, a number of steps remain to complete the product that we use, but I won't include that here. Many of us often forget how useful oil, or petroleum actually is, outside of powering cars and planes. These? Made from oil. These? Also made from oil. These? Oil again. And don't get me started on Vaseline. Its inventor, Robert Chesapeake, ate a spoonful of the petroleum jelly every day. Even these little guys might have oil inside of them. Vitamin A, or retinol, originates from beta-carotene, which can be derived from acetylene, a very common oil refining product. Virtually all industrial products have something to do with petroleum, so there's no surprise as to its transformative effect on national economies. With all of that money coming in, there's bound to be problems. Very big problems, actually. On one hand, there's the obvious environmental pollution that oil extraction generates. In 2010, this oil rig exploded, wiping out an insane number of sea animals and causing health risks that can still be felt right now. Keep in mind that oil contains these aromatic compounds that can kill you right away, or give you cancer at a later time, in other words carcinogenic. And yes, there is also the problem of this and this. Unfortunately, humanity remains terribly addicted to oil, even starting conflicts just for the sake of it. As of right now, there is simply nothing like petroleum, so its value as a commodity remains high, and even more so as global reserves dwindle. Clearly something needs to be done, and fast. If current rates of consumption persist, We have about 50 years left of oil, meaning that many of you watching this video will likely see the end of oil in your lifetime. Although not without their flaws, electric vehicles are on the rise, displacing oil consumption substantially. You don't even need a vehicle to change things, simply walking or riding a bike can do the trick. If available, public transportation is a very powerful tool, since they reduce the number of vehicles on the road, simultaneously curtailing emissions and congestion. Still, planes and ships depend a lot on oil, and these aren't things that you can electrify right away. Specifically in the case of planes, batteries incur too much weight in exchange for the energy they provide, while jet fuel gradually burns away in the course of the journey. A flight from New York to Seoul, for example, will never be electric, at least in the near future. Sun Tzu once said, "To know your enemy you must become your enemy." Thus the solution to the oil problem is not to remove it entirely, but to create some sort of imitation oil. If you've ever heard of E. coli, that may be due to the unpleasant health problems they tend to cause. But history has shown that mankind can domesticate almost anything, and as of right now E. coli is like a lab mouse of bacteria. In case you didn't know about this, insulin made by genetically modified E. coli makes up a significant proportion of global production. Since the insulin molecule itself is much more complicated, there exists a promising possibility of formulating oil like hydrocarbons, although this remains more expensive than just drilling for the stuff itself. Nonetheless, with the likes of ExxonMobil already in action, there is still a lot we can look forward to in the coming years. Of course, there is always the more classical option of chemical synthesis. Among the more well-known methods is the process developed by German chemists Franz Fischer and Hans Trispsch in 1926. First, coal or natural gas is converted into a mixture of carbon monoxide and hydrogen. Subject the mixture to a sufficient combination of temperature and pressure, toss in some agitators and you get the hydrocarbons commonly found in petroleum. Next year marks the centennial of this method's invention, yet the Fischer-Tropsch process remains useful when you don't have that much crude oil laying around. Specifically, it was Germany itself that had to rely on this, during World War II when oil wasn't exactly something that the country had in abundance. Once again we witness the terrible but undeniable importance of oil, the lack of which both determined Germans' strategy and cost them the war. So, in a way, I guess you can say that oil saved the world. Oil is not the only thing that a Fischer-Tropsch mechanism can generate. Scientists have found amino acids and even nucleobases inside asteroids. Does nucleobase sound familiar? You may know that the deeper you get inside the Earth, the higher the temperature and pressure becomes, and this is the same thing that happens with big enough rocks. If there happens to be some metal lying around, a perfect Fischer-Tropsch condition is created. Throw in the necessary ingredients, and you get the building blocks of life. In 2023, samples returned from asteroid Bennu by NASA's OSIRIS-REx spacecraft revealed the presence of all 5 nucleobases of DNA and RNA, along with high levels of ammonia. Therefore, it's highly possible that both you and I are carrying some degree of extraterrestrial DNA, and so these guys might not be as distant as you may think. Like a sort of virus, they went planet to planet, exploiting natural resources until nothing was left. Do you see a pattern? If you do, comment down below, and thanks for watching.